So hello, a very good afternoon to all and welcome to the class. So in this class, we are going to see the solution of our AIT second paper, right? So I hope सबने paper अच्छा किया होगा. All of you did your paper very well, right? So in this video, we are basically going to see the solution of that question paper, right? And I'm going to explain you questions or method in which you are facing some problem, right? So let's start with the today's session. Okay. So the first question is this is the first question in your chemistry paper, right? So a gaseous mixture contains CO2 gas and N2O gas in a 2 ratio 5 by mass, right? The ratio of the number of molecules of CO2 and N2O is. So you have to calculate the ratio of the number of molecules. So already is given, right? And you have to calculate the number of the molecule of CO2 and N2O. So this is a very simple question from the mole concept. I hope all of you did this question very well, right? So let's see the solution of this question. Okay. So what data is given in this question basically? So mass is given, right? So mass of the CO2, that is the mass of CO2 and the ratio of the mass of N2, right? Mass of N2. So this is already given. This is equal to 2 ratio 5. Hmm? So this is given 2 ratio 5. So can you calculate the number of moles? Because mass is given, so we can easily calculate the number of moles also. Okay. So how will you calculate the mass beta? We all know that what is mole. So mole is nothing but mole is equal to mass divided by molecular mass, right? That is mass of that solute divided by the molecular mass. So if you use this formula only, then what is the formula for writing the mass? So we can write the mass is nothing but this is equal to number of moles into the molecular masses. Clearly we can write this. Okay, so let me write for the CO2 and N2. So for the CO2, that is the number of mole of CO2 multiply by molar mass of the CO2. Similarly, for N2, number of mole of N2, right? And into multiply by molar mass of N2. And this is equal to 2 by 5, right? This is equal to 2 by 5. So on substituting this value, right? So both having the same molecular weight as you compare the molecular mass of CO2. So what is the molecular mass of CO2? Can anyone tell me? Yes, the molecular mass of CO2 is nothing but 44, right? 44 gram per mole. How will you calculate this? Because we know that carbon having the molecular mass 12 and O2 having 32. So this is equal to 44. Similarly, for the molecular mass of N2O, we know that for N2O, we have N2 that is 28 and oxygen we have 16. So this is also comes out to be 44 grams. So they having molecular mass same. So this and this will be cancelled because they having the same molecular mass. So the ratio comes out to be same. That is 2 by 5. Right. So this is the ratio of the number of molecules of the CO2 and the N2. Right. So this is how we can calculate this. So what is the correct answer for this question is? So the correct answer for this question is 2 ratio 5. Right. So this is how we can calculate this. So I hope this is clear to all of you. Sure. Now, the next question is that is question number 52. So in this question, they are asking the number of oxygen atom in 4.4 gram of CO2, right? That is the number of oxygen atom in 4.4 gram of CO2. So they are asking what is the number of oxygen atom in 4.4 gram of CO2. So this is also a mole concept question, and this is a very, very easy question. So we all know that from the basic concept of mole, that is one mole, right? That is one mole is equal to 6.023 into 10 raised to the power 23 atoms, molecules or ions, in this case, atom of oxygen, right? Atom of oxygen. So 1 mole is equal to 6.023 into 10 to the power 23 atom of oxygen. Similarly, we also known as 1 mole is also equal to the molecular mass of that molecule. So 1 mole is equal to molecular mass. So in this CO2, the CO2 having molecular mass 44 gram. Just we calculate here, right? So we can say that is 44 gram of CO2. 44 gram of CO2 having how many atoms of the number of oxygen atom better? So we can say that the 44 gram of CO2 having that is 6.023 into 10 raised to the power 23 atoms of CO2 only, right? CO2. But in this question, they are asking only about the that is the number of atoms for the oxygen only. So they are asking only for the oxygen. So how will you calculate for the oxygen better? Can anyone tell me how will you calculate for the oxygen only? Yes, we know that that is the 44 gram of CO2 contain this much. So simply just using a unitary method, we can say that 4.4 gram of CO2. That is 4.4 gram of CO2 contain 6.023 10 raised to the power 23 divided by 44 into 4.4. So this is a very simple unitary method. For example, if 44 gram contain this much atom of CO2, then 4.4 gram contain this much. So on solving, what you'll get better? On solving, you'll get this will cancel out each other. 10 raised to the power, this will become 22. So this is 6.023 and this is 10 raised to the power 22. Right. So one molecule of CO2 contain how many atom of O2? Can anyone tell me? Yes. So one molecule of CO2 contain, yeah, I can write here one molecule, that is one molecule of CO2 contains, right? So the one molecule of CO2 contain two oxygen atom. तो इसमें दो ऑक्सीजन एटम है, टू ऑक्सीजन एटम. So the one molecule of CO2 contain two oxygen atom. So the molecule of CO2 कितना हो जाएगा भाई, जल्दी बता दो फटाफट. So the in one molecule of CO2 how many oxygen atom are there? That is 2 into 6.023 into 10 raised to the power 22. So this comes out to be 12.046 into 10 raised to the power 22. So which option is correct, beta? Yes. Out of this, which option is correct? Yes, that is option number A. Here 10 raised to the power 23 and this is the 12 into 10 raised to 20. So the both are same. We can also write as 1.2 into 10 raised to the power 23. So this is how we can actually write this. Okay, so I hope all of you understand this question very well. So this both these two questions are from the mole concept only, right? So this is how you can actually solve the question related to the mole, right? So this is how we can calculate the number of oxygen atom in the one molecule of CO2. Now let's see the next question. So the next question, that is question number 53. We are going to solve 53 first, then we are going to solve 54. So in question number 54, what they are asking basically. Yes. So in question number 53, they are asking 10 gram of hydrogen and 64 gram of oxygen were allowed to react in the steel vessel. Amount of water produced in this reaction will be. So this question is also belong to the mole concept chapter, that is from the limiting region concept, right? So in this, the 10 gram of hydrogen and 64 gram of oxygen. So we know that the normal reaction for the production of water is H2 plus half O2, right? And this will gives us H2. So this is how will you write the reaction. Okay. So for this, we can easily calculate the value in terms of the gram as well. So in this question, they are given 10 gram of H2 and 64 gram of oxygen. So this is 64 gram of oxygen and they react with to produce how much amount of water. So this is what they are asking the question. So first of all, calculate the limiting reactant out of the following two, hydrogen or oxygen. So here it is given that this is a 2 gram and this is O2 32 and 16 gram. 16 gram, right? So we know that that is a 16 gram, or we can say that 16 gram of oxygen, 16 gram of oxygen required. How much gram of hydrogen beta? That is 2 gram of hydrogen. According to this equation, we can say that the 16 gram of oxygen required 2 gram of hydrogen. So similarly, 64 gram required 64 gram of oxygen required. How much beta? That is 2 upon 16 into 64. These all are the unitary method question. So 16 fours are 8 gram. So they want 8 gram of hydrogen. But in this question, hydrogen is 10 gram. So which one is the limiting reactant beta, right? So we know that here they require only 8 gram of hydrogen, but hydrogen is in 10 gram. So this is an excess, right? So here we can clearly see that excess reagent is hydrogen. So which one is excess reagent beta? Hydrogen. So hydrogen is excess reagent. Hydrogen is excess excess region. How will you say that hydrogen is the excess region beta? So we can say hydrogen is the excess region because in this question only 8 gram of hydrogen need to be required, but here in question 10 gram of hydrogen is given. So we can say that the hydrogen is present in a excess region. So which one is the following is the limiting? Yes, obviously if the hydrogen is in excess region, then oxygen will be the limiting reactant, right? So oxygen will be the limiting reactant. So it is very much clear that oxygen oxygen is limiting reactant. Okay, so oxygen is limiting reactant. Just remember this. Clear? Hai? So oxygen is limiting reactant here. So we know that the product formation is totally based on only upon the limiting reactant only. That how what amount of product is formed is totally based upon only upon the limiting reactant. So we know that in the equation that is half O2 and this will produce H2. Right? This is the whole equation actually. H2 plus half O2, this will produce the H2. So we can say that according to the question, that is 16 gram of oxygen. So 16 gram of oxygen will produce how many gram of H2 beta? That is 18 gram. है ना? 18 gram of H2. So in the question, how many gram of fuel? 64 gram of oxygen is given. So 64 gram of oxygen. ठीक है ऑक्सीजन प्रोड्यूस that is 18 divided by 16 into 64. So 16 fours are 8 fours are 18 fours are 72, right? So this is nothing but 72 gram. So 72 gram is produced, but in this question they're asking in the number of mole. Okay, so you can easily convert this. How will you convert 72 grams? So can you convert 72 gram of water into the number of moles? Obviously, we can convert. That is 72 upon my molecular mass. That is 18. So that comes out to be 4 mole. So the correct answer is 4 mole, right? So which option is correct? That is option number D. So option D is the absolutely correct one. That is the 4 mole. So the 4 mole of hydrogen will be produced in this reaction. So I hope this is clear to you, all of you. सबको clear है? Good. So this is how we can solve this question. Now let's move to the next question. That is the hydrated salt of Na2SO4.XH2O on heating loss 55.9% of weight and become anhydrous. The value of X is. So you have to calculate the value of this X, right? So you have to calculate the value of this X and the hydrated salt Na2SO4.XH2O on heating losses 55.9% weight and become anhydrous. You have to calculate the value of X on for this question. ठीक है? चलो तो calculate करते हैं फटाफट. So now let us consider that is so let us consider 100 gram. ठीक है? So consider 100 gram of Na2SO4 of Na2SO4 dot XH2O. So let us consider the 100 gram of Na2SO4 dot XH2O. Out of this, 55.9 gram of water is completely lost water to form anhydrous. And it is given in the question. That is 55.9% on heating loss, 55.9% weight and become anhydrous. Right. So out of the 100 gram, 55.9 gram, 55.9 gram, almost 56 gram. The 55.9 gram is water, as it, है ना, as it completely ठीक है losses water. ठीक है, so इतना तो डिहाइड्रेशन हो गया है. Now amount of water left is, so amount of water is how much? So amount of water, we know that amount of water is already given, that is 55.9 gram. right? So basically a salt which is in 100 gram, out of this 55.9 gram is hydrated, right? So 55.9 gram is a water and rest is a salt. Now, can you calculate the number of moles? Yes, we can calculate. So in the terms of number of moles, so for the number of moles, just divide by the molecular mass. So this is 55.9, or we say 56 divided by the 80. So what you will get, that is almost 3.1 gram. Okay. So this is comes out to be 3.1 gram. Now, what is the amount of Na2SO4? So amount of Na2SO4, Na2SO4 dot XH2. So first of all, calculate the amount of Na2SO4. So amount of Na2SO4 is nothing but 100 minus 55.9. Hmm? So this comes out to be around 100 minus 55.9. This comes out to be 44.1 gram. Clear? So this comes out to be 44.1 gram. Hmm? Now, just calculate the number of moles here also. So the number of moles, just like the water. So here number of moles is also equal to, that is, this is equal to 44.1 gram, and this one is divided by their molecular moles. This is 142. So this comes out to be 0.31 mole. Done. So this comes out to be 0.31 mole. So 0.31 mole this will comes out to be. So we know that 1 mole of Na2SO4 has a, so this much mole of this contain 0.31 mole, right? So now you can easily calculate this. That is the 1 mole of Na2SO4, that is 1 mole of Na2SO4, right? Has how much? Has 3.1, because 0.31 mole of N2SO4 has a 3.1 mole of water. This is very much clear from this equation, right? That is 0.31 mole of Na2SO4 having 3.1 mole of water. That is in mole. Okay. Okay. So if the 0.31 mole contain 3.1 mole of water, then the 1 mole contain beta 3.1 divided by 0.31 mole. That comes out to be the 10 mole of water. 10 mole of water. So what is the value of x here? X comes out to be 10. So this is the value of x in this question, right? Because in this question they're asking the number of water mole. Hmm? So considering the 100 gram of NaOH of water access to, the 155.9 gram of water is completely losses water. So amount of water left is this. So we can easily calculate by using this formula. So I hope this is clear to you, all of you. Hmm? Sabko clear hai? Okay, very good. So this is how will you actually solve this question. So this is the question number 54 for you. Now, let's move to the question number 55, right? So what the question number 55 basically asks. So in the question number 55, it is given if the 10 raised to the power 21 molecules are removed from the 200 milligram of CO2, then the number of moles of CO2 left will be, right? So if the 10 raised to the power 21 molecule are removed from the 200 milligram of CO2, then the number of moles of CO2 left. So you have to calculate the number of moles of CO2 left with B. Chalo. So basically, if the 10 raised to the power 21 molecules are removed from the 200 milligram of CO2 only. So let us see number of moles of 200 milligram of CO2. So we can calculate now number of mole of 200 milligram of CO2. So the number of moles in the 200 milligram of CO2 is nothing but this is equal to 0.2, that is the mass, है ना? Milligram में और mass is given in the milligram, so we can convert gram. So 0.2 and divided by the molecular mass. So this is the mole, right? So this is what come out to be mole. So the number of molecules for this. So what is the number of molecules for this? Nothing. It is equal to number of molecules. So if you know the number of moles, you can easily calculate the number of molecules. So the number of molecules is nothing but 0.244 into 6.023 into 10 raised to the power 23. Just multiply by the Avogadro number. So on solving, what you will get? You will get nothing but 2.73 into 10 raised to the power 21. right? So this is how what you'll get. That is the number of molecules is equal to 2.73 into 10 raised to the power 21. Now the number of molecules of CO2 left. Hmm? So the number of molecules of CO2 left. So the number of molecules of CO2 left is, how can you calculate that? So we can calculate this, that is the number of molecules of CO2. Okay? The number of molecules of CO2, that is the number of molecules of CO2 left. So the number of molecules of CO2 left is nothing, but this is equal to, how can you calculate? Right. So the number of molecule of CO2 left is, that is, we can already calculate this, that is 2.73 into 10 raised to the power 21 and subtracted by 10 raised to the power 21. This is already given in this question. Right. So solving what you will get, this is equal to 1.73 into 10 raised to the power 21 molecule. Mm. So this is given, that is 1.73 into 10 raised to the power 21 molecules. So the number of moles of CO2 left is, so the number of moles of CO2 left. So the number of moles of CO2 left is nothing but is equal to 1.73 into 10 raised to the power 21 and divided by 6.022 10 raised to the power 23. So on solving what you'll get, that is 2.87 into 10 raised to the power minus 3 mole. So this is how will you get to. Take it. So this is the value. How will you get this? Right. So this is the way to solve this question. Then good. Now, let's see the next one. That is the question number 56. So what is the question number 56? That is the ratio of the differences between the second and the third Bohr orbit to that of the third and the fourth orbit energy is. So you have to calculate the ratio of the differences between the second and third Bohr orbit energy to that of third and fourth Bohr energy, right? Right. So let's see the next question. That is the 56th question. So the ratio of the differences between the second and the third Bohr orbit energy to that of the third and the fourth orbit energies. So you have to calculate the ratio of the difference between the second and third. So I hope this is a very easy question. All of you did this question very correct, right? So this is from the Bohr energy question, Bohr energy or radius question, right? So in this we are going to use the formula of energy only. So the ratio of the differences between the second and the third Bohr orbit energy to that of the third and the fourth orbit energy you need to calculate. So let's see the solution for this question. Hmm? Okay. So this is the question number 56. So how we can solve that? So we know that we know that very simple value, that is in terms of electron volt. You can write energy is nothing but is equal to minus 13.6 divide and this is divided by n square z square. Hmm? N square into z square. This is in electron volt. So unit here, it's very interesting to note the unit here. So the unit here is electron volt, not joule, right? For joule, you have a different formula like 2.18 into 10 raised to the power minus 18 something, right? So you have to use either of this formula because in this you are going to calculate the ratio of the energy. So this is the formula we have. Now this is from where to where we need to calculate. That is from second to third and from third to fourth, right? So let's calculate for the second to third first. So the energy change from 3 to 2. That is nothing but minus 13.6 and the Z square value is 1 for the hydrogen. So in this we have a the ratio of energy for the Bohr orbit. Right. So for the hydrogen, Z is always 1. So one thing we have here, that is we have to subtract this from 1 upon, that is n. So n here is 3 pi square and this is nothing but 2 square. Right. So this is 2 square. So the value comes out minus 13.6 and this comes out to be 1 minus 9, 1 minus 4. So on solving what you'll get beta. So on solving you'll get minus 13.6 into, and this comes out to be minus 5 and 9 for the 36. Right, that is 36. So minus minus cancel out each other. So this will become 13.6 into 5 upon 36. So this is when the energy difference is between 3 to 2. Similarly, when the energy difference is 4 to 3. So for the 4 to 3, this is 13.6, and this is 1 upon 4 ka square, and this is 1 upon that is 3 square. So on solving, what you'll get, that is 13.6, and this is nothing but that is 16, right? So on solving, you'll get that is minus 7, and this will divided by that is 16 into 9, right? So now you just need to calculate the ratio of these two, that is this one and this one. So on calculating the ratio of, that is delta E 3 minus 2, delta E 4 minus 3. So if you calculate the ratio, you get the 20 by 7. So this 20 by 7 is the correct answer. Right. So this is how we can solve this question actually. Now, let's move to the next question. That is question number 57. So this question is the ratio of the energy of the photon of wavelength 200 nanometer to that of the 400 nanometer. So this is a very simple question. We all know that this question is from the Planck's quantum theory. That is, we know that that is E is equal to h mu. E is equal to h mu. Or we can also write it mu is equal to C upon lambda. So we can say that energy is inversely proportional to the lambda, right? So the ratio of the energy of the photon of the wavelength 200 nanometer to the 400 nanometer. So just need to calculate the ratio of the energy. So how will you calculate beta? That is E1 upon E2. This is nothing but equal to lambda 2 upon lambda 1. They are inversely proportional to each other now. This comes out to be 400 divided by 200. So this comes out to be 2. So 2 is the correct answer for this question. Now, move to the next question, that is question number 58. So in an atom, which subshell is filled by the electron after the 4p? So this question is from the above principle. It's a very simple to remember this, right? So if you learn the series, we know that this is 1s, we have 2s, 3s, 4s, we have 5s, we have 6s. See here, from here we have a 2p, we have a 3p, we have a 4p, we have a 5p. Similarly, from here we have a 3d, we have 4d, we have 5d, and from here we have a 4f and 5f, right? So how will you remember the arrow? Like this. Hmm? Like this only. Clear? Okay? Good. So this is how will you remember the uh, particular arrow. So first of all, you need to fill the electron in 1s, 2s, 2s. Then this question is asking in an atom which subset is filled by the electron after 4p. So where is the 4p? Yeah, 4p. So after 4p, we have a 5s. So which one is correct? That is option C. The 5s is correct. After 4p, we have 5s. So you have to fill electron in the 5s. So this is how we actually by using a bow principle, actually we know that the electron is filled according to the increasing level of energy, right? So the after 4p, the next shell in which subshell in which we fill the electron is 5s. Okay? Sure. Now let's move to the next question. That is question number 16. So they are asking arrange the following oxide in the decreasing order of their acidic strength, right? So you have to arrange it in the decreasing order of their acidic strength. So which of the following is the more acidic and which of the following is the less acidic? So we know that whenever the central metal atom having the higher oxidation state, so if the plus oxidation state, right, plus oxidation state increases, acidic character also increases. Acidic character also increases. So out of these, we know that which one is so higher, that is this, and showing here and having shown maximum oxidation state. Then after this, we have a S, right? And then we have a CO2, and then we have a silicon. Right, oxidation state as well as the electron activity of the element, both different, right? The order of the acidity of the above formula is because with the help of SiO2, what you will make, with the help of NO2, what you will make. So this all actually give rise the acidic strength. For example, if I'm considering HNO3, if I'm considering H2SO4, that is H2CO3, and this is H2SiO3. So this HNO3, right? This so having the higher acidic nature, right? So this will show the highest acidic behavior, HNO3, and this will form from the oxidize of N2O5, right? And then SO3 comes. So the correct order is B. Sure. Let's see the next one. That is the electronic configuration of the four element, that is A, B, C, and D are as follows. Which one will be the highly electropositive? So you have to identify which of the following will be highly electropositive. Either it will be A, B, C, and D. And the electronic configuration of the four elements, that is A, B, C, D are given. Right. So A, we have a 2, 8, comma 4. So this is the 14th group element. 2, 8, 8, 12. So obviously that is element C because this belongs to the first group, right? And we all know that the first group, that this is the electronic configuration of the potassium. So the first group element are highly electropositive in nature. So that's why the option C is correct. So this is a very, very easy question. I hope all of you did this question, right? Hmm. Now, let's move to the next question, that is 62. That is the element which has the greatest difference between the first and the second ionization energy. So you have to calculate the element which has the greatest difference, right? So we all know that that is the for the alkali metal, because alkali metal having a general electronic configuration of NS1. This is the outer electronic configuration, right? So if you remove one electron, then for the second electron, we have to remove electron, just like in case of a potassium, we have the electronic configuration like this. So if you remove the one electron from their outermost cell, its ionization enthalpy is very low, right? Ionization enthalpy is very low when you remove this one electron, because this electron is very far away from the nucleus and they are very, loosely bound and they can easily remove out. Now, for the next electron to be emitted, you have to emit electron from this valence fully filled electronic configuration, which act as a noble gas configuration, which is very difficult. So they having the ionization enthalpy very, very high, right? So the only this alkali metal, the difference of first and second ionization enthalpy is very, very high. So which one is the correct one? That is the sodium, right? Sure. Now, the increasing order of the screening effect of the electron is the SPDF. So we all know that for the screening effect, what is the correct order, right? So the correct order for the scaling is S, P, E, and F, right? S, P, D, and F. S orbital are spherical in nature and they are very closer to the nucleus, right? So S are very spherical and closer to the nucleus, but P, D, and F orbital are diffuse and they show the poor shape, right? They show the poor difference, where the S orbital has a spherical shape and they lie near to the nucleus. So they show higher splitting effect. So the correct order is A. Now, move to the next question, that is question number 64. So, which of the following is the most electropositive element? So, I guess that these five, six questions are very, very easy questions. They are the very, basic questions. I hope all of you did this question very correct, right? So, which of the following is the most electropositive element? So, we have a calcium, chlorine, and we have a carbon and potassium. And they're asking which of the following is the most electropositive. Always we know that the first group element are the highly electropositive, and as we move from the left to right in the periodic table, the electropositive values decreases, right? Now, the next question is the correct order of the electron activity of N, O, F, and P is, right? Electron activity they're asking. So we know that this is F, O, N, and this is P. So this is the general. So this is from the 15th group. This is from the 16th group and this is from the 17th group. So we all know that as we move from left to right in the periodic table, that is from group 15 to 17, the electron activity value increases. So the most electron active element is no doubt fluorine, right? So the most electron active element is fluorine. Now, after fluorine, the next one is oxygen, and then nitrogen and phosphorus. Because down the group, the electron activity values decreases, right? So the correct order is option A. So very, very simple question is all. Now, the next question is the ions O2 negative, F negative, Na plus, Mg2 plus, and Al3 plus are isoelectronic and they are ionic radii. So what about their ionic radii basically? So what are the isoelectronic beta? So isoelectronic are those which contain the same number of electrons. So which having the same number of electrons. So those species which contain the same number of electrons are known as isoelectronics, right? Now you have to arrange them in order of their ionic radii, right? So we know that the most negative charge is possessed by O2. So O2 negative is larger in size then F negative, then sodium plus, then Mg plus 2, and then Al plus 3, right? So this is the order. So this is the order of the ionic ratings. Which option is correct? That is ideas in radius increase from O2 negative to fluorine negative. Wrong. A decrease from O2 negative to the fluorine negative, and then no. A significant increase from O2 plus, a significant decrease from O2 to this. So this one is a very, very correct. That is a significant decrease. O2 negative as the highest and Al plus 3 as the lowest. So this is the option D is absolutely correct for this question. Okay? Chalo. Next question is question number 67. So which one of the following arrangement represents the correct order of the least negative to the most negative electron gain enthalpy? So this question is from the electron gain enthalpy. What is the electron gain enthalpy, beta? That is the amount of energy released or absorbed when the one extra electron added to the atom. So they are asking which of the following element represent the correct order of the least negative to the most negative. Right. So let me write the group of all the elements. So aluminum. First of all, write calcium. This is belong to the second group. And then we have aluminum, right? This belong to the 13th group. Then we have a carbon. Carbon belong to the 14th group. And then we have a oxygen belong to 16th group, and 17th group we have a fluorine. So we have to arrange this according to the electronegativity values. So we know that as we move from left to right, the electron gain enthalpy, sorry, not electronegativity, sorry, electron gain enthalpy. So we also know that just like a electronegativity, as we move from the left to right in the periodic table, electron gain enthalpy will be increased, right? Some exceptions are there, but in this, because all these elements belong to the third period, so in this, there is no exception, right? So we know that fluorine belong to the 17th group. The fluorine is the most one. After we have a small exception here, right? So we have a small exception in this. So what is the exception, beta? That is less negative, right? So we have the less negative is that is the calcium. Hmm? That is the calcium, and then we have aluminum, then we have C, then we have O, and then we have F. So which option is correct, beta? Calcium, aluminum, C, O, and F. So option number D. Right. So question number 67, the option D is absolutely correct, right? If they are asking between fluorine and chlorine, then you need to remember the cases, exceptional cases, right? That is, chlorine supposed to be less negative, but actual chlorine is a more negative than fluorine due to the electronic repulsion, right? So this is from the exceptional case, but this question is very simple because all the elements are from group 13 elements. So you just need to remember the group number. If you know the group number, then you can easily identify which will show the most electron gain enthalpy and which will show the least. Now, the next question is, in which of the following molecule there is one electron in the axis of electron pair? So you have to identify in which of the following molecule there is one electron is axis of electron pair, right? So if you see BF3 is the Lewis acid, right? So this will not happen. BCl2, in this there is no electron left because this show the zero lone pair of electron, B having two valence electron, and those three Cl bond are formed. In SF6, there is no all six are occupied by the fluorine atom. So only in case of NO only, right? So only in the case of NO, we have uh, 15 electron, that is 7 electron from N and 8 electron from the oxygen atom. So this is in which we are calling there is one electron in the axis, right? Now, so this one is the correct one. Question number 69. The number of anti-bonding electron present in O2 negative molecule. Right? So you have to calculate the number of anti-bonding electron present in O2 negative molecule, right? So what is the electronic configuration of this O2 negative molecule, beta? Can anyone? Hmm? Can anyone tell me the number of anti-bonding electrons present in the O2 negative molecule ion, right? So we know that for the O2 negative molecule ion, how will you calculate this? Hmm? That is 7, right? Let me write there. How will you calculate this? So for the O2 negative molecule, how will you write the electronic configuration? That is, this is nothing but sigma 1s2. This is sigma star 1s2. This is sigma 2s2. Sigma star 2s2. This is sigma 2p. This is sigma 2p x2. This is sigma 2p y2, and this is pi 2p z2, and this is pi 2p z2 हो गया. चलो. Now we have pi star 2py2 and is equal to pi star 2pz1. Okay. So this is how will you calculate. Hence the number of anti-bonding electrons. So here the number of anti-bonding electron is 2. So here 2, 2, 4, 4 and 2. 4, 2, 6 and 1, 7. So total 7 electron we have. So in this question, you have to calculate the number of anti-bonding electron present in the O2 negative molecule. So the number of anti-bonding electron present in the O2 negative molecule is 7. Now, move to the next question. That is, which one of the following has a no unpaired electron? So just like the previous question, this question is also from the MOT theory. So we know that that is O2 twice negative, or if you write the electronic configuration just like the previous one, that is sigma 1 is to sigma star 1 is to sigma 2 is sigma star 2 is to, you'll observe that O2 twice negative has no unpaired electron. How will you write also? Because we know the oxygen 16 and 218, so they have an even number. So they do not have any unpaired number of electrons. Okay? Now, which of the following can never represent the empirical formula for the compound consisting A and B? Right. So you have to calculate which of the following can never represent the empirical formula. So always remember this empirical formula, the ratio of the number of atoms in the molecule has to be simple whole number ratio. And this is 2 by 8 is not the simple ratio, right? That is this one, that is 2 by 8. This is not the simple whole ratio. That's why this can never be an empirical formula. For empirical formula, the ratio of the number of atom in the molecule has to be simplest number ratio, that and 2 by 8 is not such a ratio, right? So this is why this will happen. Now, let's see the some numerical mode. So basically, from question number 62 to 70, these 8, 9 questions are very, very easy questions, right? So all of you did this question very correct, right? These all questions are very, very easy questions. Now, let's come back to the numerical part again. So the total number of electron in the 1.4 gram of dinitrogen gas having atomic number 7 is, so you have to calculate the total number of electron. So we know that if I'm considering that is 1.4 gram of dinitrogen. So what is the number of moles? That is mass divided by the molar mass. So this is the mole of N2. So in 1.4 gram of N2, this much mole of N2 is present. So 1 mole of N2 contains 1 mole of N2 contains. So 1 mole of N2 contains 14 6.023 into 10 की power 23 left. ठीक है. So you have to calculate for the this much of mole 1.4 into 28 mole. So this will contain 1.4 28 14 6.023 10 raised to the power 23. So this much of electron. So this is 2. So 1.4 divided by this. So this comes out to be 4.2 into 10 raised to the power 23. Chicken. So this is how we can actually calculate the number of electrons. So which one is the correct one? That is for 72. Option Option A is absolutely correct answer for this question. Okay. Chalo. Let's move to the next question. That is the question number 73. 70 kg air sample contain oxygen 65%, carbon 25%, hydrogen 10%, and nitrogen 2.5%. The weight in which the air sample would yield if all H1 atoms are replaced by the H2 atom. So you have to calculate. So this question is very, very important and very interesting question as well. So let's see the solution for this question. So this is the 72, right? So this is the 72 question, right? So let's see how will you solve this question. Oh, so sorry, this is 73. 72 we already covered, right? This is the 73, question number 73. So 10%, so 10% of hydrogen is present by weight. ठीक है. So 10% of hydrogen is present by weight in the 70 gram air sample. In 70 kilogram air sample. ठीक है. So 10% of hydrogen is present by weight in 70 gram of air sample. Hence the mass of the hydrogen present. So if you calculate the mass of hydrogen, so mass of hydrogen present. ठीक है. So the mass of hydrogen present is nothing but 10 divided by 100 into 70 kilogram. So that comes out to be 7 kilogram. ठीक है. So mass of hydrogen present is 7 kilogram. Now if all H1 are replaced by H2, then the mass of hydrogen will get double. Similar, obvious here. If this is 1H1 and this is 1H2. So if this 1H1 is replaced by 1H2, then the mass will get double, right? So how will you say that? The mass of the hydrogen present will get double since H2 is twice as heavy as H1. Therefore, there is an increase of 7 kg. So what is the total mass then? So total mass is so there is a increase in 7 kilograms, right? So the weight which in the air would be if all H atom are replaced by this. So we can say that the total increase is 7 gram. So in this question, what they are asking, the 70 gram of air sample contains 65% nitrogen. The weight which the air sample would gain, they are asking gain. कितना weight और gain करेगा? So पहले से 7 था, 7 किलोग्राम और gain कर right? So this is the 7 kilo. Okay. Let's move to the next question. This question is also very simple. That is, in this question, you have to calculate the unknown surface irradiated with a photon and unknown particles are emitted from the surface. That is, follow the photoelectric equation. Calculate the threshold frequency. So you have to calculate the threshold frequency, right? So how will you calculate the threshold frequency, beta? So we have a two experiment is given, right? So we know the Einstein photoelectric equation. So according to, let's see the question number solution for the question number 74. Huh? So let the mass of the particle emitted is m and the kinetic energy. We know the formula according to Einstein photoelectric equation, that is kinetic energy is equal to h and this is v minus v naught. Right? We can also write kinetic energy is half mv square. With all formula are correct. So you have to calculate this mu naught. Right? This is called the threshold frequency. So for the first case, how will you calculate the mu? For the first case, because lambda is given and the velocity is also given. So velocity is given and the lambda is given. For the first case, for the first case, right? For the first case, you can calculate frequency is equal to C upon lambda, right? C upon lambda. What is C here? So C is nothing but 3 into 10 raised to the power 8. What is 3 upon lambda? Huh? What is lambda here, beta? So lambda is given is nothing but 500. Huh? So this is equal to 500 into 10 की power because this is a nanometer. Na? So this is 10 raised to the power minus 9. So this is how we do calculate. From solving what you'll get 6 you'll get 6 into 10 raised to the power 14 second meters. So this is the value of the frequency from that equation. Similarly, from the second experiment, we'll get the value. So when you put the value in this equation, what you will get? Can you tell me? So kinetic energy is half mv square. So this is half. This is m. What is v? V is given. That is first. That is 1000 into 10 raised to the power 5 and square of it. Okay. So v into 10 raised to the power 100 into 10 raised to the power square, and which is equal to h, and this is mu minus mu naught. So what is mu? Mu is already given. I think we already calculated. This comes out to be 6 into 10 raised to the power 40 minus mu naught. So this mu naught we need to calculate. Check it. So on solving the second equation also, so we have 1 And for the second equation also we get the same formula like half m, and for the v square we can say that this is 200 into 10 raised to the power 5 plus square. This is h, and for there we can also calculate c upon lambda minus v naught, right? So on this, from these two equation we can easily get the value of v naught, which comes out to be 5.77 into 10 raised to the power 14. So this is how we'll actually calculate it. So I hope this is clear to you कि कैसे solve किया आप लोगों ने इसको. हम्म चलो, let's move to the next question, that is question number 75. So in this question they're asking the frequency of the light emitted from the transition N4 to N2 for the helium is equal to that of the transition atom of which of the following. So basically they're asking frequency. So let me solve this question. So the frequency of helium is equal to frequency of hydrogen. When? Right. So helium frequency is already given there. That is the energy of helium N is equal to 4, है ना? 2, N is equal to 2. Similarly, hydrogen के लिए energy N is equal to N1, 2, N is equal to N. Done? Now, we know that if we put the values, what the value we have? We know that E is equal to RH Radical constant into Z square. This is 1 upon N1 का square minus 1 upon N2 का square. ठीक है? N1 का square, N2 का square. So on solving, you will get, because RH is equal to 1 here. So substitute the value, you will get the option that is by from the various option, that is this one, that is 2 and 1. So this one is absolutely correct, right? So option B is absolutely correct, because for this only, this frequency, that is the frequency of helium is equal to frequency of hydrogen. So when you put all this value, come to know that this option is equate this N2 and N1, right? So this is the correct answer for this question. Now, let's move to the question number 76. So this question is from the quantum numbers, right? So what the question basically asks is, so among the following sets of quantum number, which one is not possible? So n and n both are 3, which is not possible, right? This one is not possible because n is and L is always n minus 1. So if n is 3, L must be equal to 0, 1 and 2 only, not 3. So this is absolutely correct. Incorrect. Now, choose the arrangement which show the increasing value of the charge by mass ratio. So this is a very simple question, and this is totally, all of you know that is the ratio of the charge by mass of electron, proton, neutron, and the alpha particle, right? So you have to calculate. So we know that the only magnitude of charge, not negative sign, will include it. So if you compare this, so which will show the arrangement, that is electron having the highest charge by mass ratio after this proton, and then alpha particle, and then the neutron. So neutron will be the lowest and electron will be the fastest. Okay. Sure. Now move to the next question. That is the pair of ion having the same electronic configuration as the atomic number chromium 24 Fe. Right. So you have to identify the element which shows the same electronic configuration. So Fe3, we know that Fe3 we have 3d5 and Mn plus 2 also 3d5. Right. So these all show the same electronic configuration. This one is correct. Now, in copper plus, the number of cell occupied, the copper subcell occupied, use orbital and unpaired electron respectively. So you have to calculate in copper plus the number of shell. So you have to first off you have to calculate the number of shell. So in copper plus the number of shell is, because copper plus. So this belong to the 3D third period. So they having the 3D copper generally 3D10 and 4S1, but copper plus 1 having only 3D10, right? So 3D10 they are asking copper plus the cell occupied. So third cell they are occupied basically. So 79, yeah, third cell. So these all having 4, 4, 4. This also 3. Now the next is used orbital. So this is the cell occupied, subcell occupied. So subcell occupied is equal to 6. And the next is this one, this. And the last one, the unpaired electron. So in this, there is no unpaired electron. So this option is absolutely correct. Zero unpaired number of electron. Okay. Chalo, let's move to the next question. That is question number 8. So which among the following justification is the correct for the electronic configuration of B5? Right, correct justification. So we can write as this one. So which of the following is that correct for the electronic configuration of the B5? You have to answer. So A is false and B is also false. Uh, yeah. So against the above principle, violation of Pauli exclusion principle and not Hunt's rule. Right. So against the Hunt's rule, against above principle as well as the Hunt's rule, against the above principle, and this one that is C. Right. So that is the C one. That is option C is true as the only Pauli exclusion principle is violated, but Hunt's rule is not right. Hunt's rule is all for favor. The violation of Pauli exclusion principle and not Hunt's rule. So this option is absolutely correct. Now, which of the following sequences correctly represent the decreased acidic nature of the oxide? So again, this question is from the acidic oxide nature. So in this you have to identify the decreasing order. So very same question like N2O3 we form HNO3, H2CO3, B2O3, BA or Li2O. So they have in the most electronegative. So the C is the correct answer. Now, which of the following statement is incorrect? The first action enthalpy of aluminum is less than that of this, right? And the second action enthalpy of magnesium is greater. This is wrong. Why? Because we know that magnesium having 2, 8, and 2. So when removing one electron, they having 2, 8, 1. So it is very easy to remove this one electron as well. So the second action enthalpy of sodium magnesium is much lower. But the second action potential of magnesium is greater than the second action enthalpy. This is wrong statement. Now, which of the following pair of the properties usually do not show the same increase or decrease behavior on moving from left to right in the period, right? So basically atomic radius and electron affinity, because when you move from left to right, electronic radius decreases, right? Decreases. But down the group, we can say that this will be increasing. As well as when you're moving from left to right, electron affinity increases. So this will not favor, right? Atomic radius and electron affinity. Now, the correct order of the ionization enthalpy. So this question is from the ionization enthalpy. So let me write the group. This is the 14th group. This is from 15th group. This is from 16th. And this is for 17th group, right? So we have an exception in group 15 and group 16. That is supposed to be group 16 having more, but due to the half-filled electronic configuration, group 15 show more ionization enthalpy. So the maximum ionization enthalpy basically is shown by fluorine, and after fluorine, nitrogen, and then oxygen, and then so this is the correct order. So here only one exception is there, that is between nitrogen and oxygen. Just remember nitrogen is group 15 element, so due to the half-filled electronic configuration, they are more stable, and due to this only they show highest ionization enthalpy. The next one is the statement that is not correct about the periodic classification of element is. So you have to identify the statement that is not correct about the periodic classification of the element is. Right. So the transition element, the 3d orbital are filled with the electrons after 3p and before 4s. So this orbital are this statement are incorrect. This is not the correct one. Right. This is very much simple from the above principle only. Okay. 86. To consider the isoelectronic species Na plus Mg2 plus F negative O2 is negative. The correct order for the increasing length of their radius. So this is also a very simple question. We know that higher the negative charge, higher will be the size, right? So what is the correct order for this? Can anyone tell me? Yes. So this one, that the O2 negative, F negative, Na and Mg. So this is the correct one. That is option number A is absolutely correct. Now, consider the following statement. That is statement one is the second action therapy potential of magnesium is greater than the other. This is very, very wrong. And the second statement is the first action therapy is always increased as we move across the period from the left to right. So you have to identify the correct option. Both A and 2 are the false, both statements, because the second action the potassium is always lower than that of second sodium, and the first action therapy always increase as we move across the group. No, it's depends upon whether we're taking the stability into factor or not. Always remember the second action therapy also may decrease or increase. So both the statement, that is the statement 1 and statement 2 are the incorrect. If the orbital energy are decided primarily on the basis of principal quantum number n followed by the L, if n is same, then Ca would have been placed in the So in which you have to place the Ca. So you have to place the Ca in the D block then, right? If the orbital area decided primarily on the quantum number, then according to the quantum number, we can write calcium in the D block. Now, the next question is question number 89. That is the correct increase order of the angle of BCF3, PF3, and the CLF3, right? So, this is also a very simple question. So, due to the presence of the lone pair, so in a CLF3, in CLF3, CL, F, F, and F. So, we have two lone pairs because fluorine 773, two lone pair we have. In PF3, in PF3, we have only one lone pair. One lone pair. And BF3, we don't have any lone pair. Right. So which one is correct? That is this one. So the correct or increasing. So this is the increasing order. सबसे ज्यादा BF3 का हो गया. सबसे कम BF3 and CF3. Right. So this is how you can actually the order of the bond angle is. The bond angle is the highest in BF3 because they have the minimum lone pair of electrons. BF3 no lone pair of electron. We can say that they are planar in structure and having 120 bond angle. Now, the correct order of the increasing bond angle is. So in this question also they are asking the correct order for increasing bond angle. So the same topic is the same concept is used. PF3, PCl3 and HCl3. So here both the central atom is same, but due to the electron activity difference, this reaction will arise. Using MO theory, predict which one of the following species has the shortest bond length. So using the MOT theory, you have to calculate the shortest uh, bond length, right? So for this, we know O2 twice plus. So this having 16 minus 2, 14, and their bond order is 3. So if the maximum bond order is purchased is 3 only. So higher the bond order, lesser the bond length. So the bond length कम होगा. तो सबसे कम bond length किसका होगा? That is O2 twice plus. Now move to the next question. That is the relative stability of H2, H2 plus, and H2 negative in the order of. So you have to identify the stability of these all. So if you know the stability for the H2, we can write the electronic configuration like sigma 1s2. H2 plus for we write sigma 1s1. Similarly for H2 negative, we can write as sigma 1s2 sigma star 1 is 1. Let's calculate the bond order. So bond order for this is 2 minus 0 upon 2. That comes out to be 1. Bond order for this, that is 1 ka square, 1 minus 0 upon 2. That is 1 by 2. Okay? 1 by 2. And for the helium negative, bond order is nothing but sigma 1s2 sigma star 1s. How will you calculate the bond order beta? So bond order is 2 minus 1 upon 2. That comes out to be 1 by 2. So which will show the maximum one. So 92, yeah, this is the question number B. S2 negative, S2 plus and S2. So S2 having the highest bond and the bond relative stability. Okay. Now, in the next question, that is question number 93, in which of the following molecule form when all the bonds are not identical. So you have to calculate in which of the following, those in which the lone pair of electron are there, they are supposed to be showing, bond angle are not identical. So basically in XAF4, we have 4 bond pair and 2 lone pair. In VF3, we have a 0 lone pair. So all the bonds are identical in XAF4. So which in C2H4, all the bonds are not CH4 bond. There is also a C carbon-carbon double bond. If you draw the diagram, we get to know that is C having diagram like this. This is H, this is H, this is H, and this is H. Right? These all are H. So C2H4, all bonds are not CH bond. So there is also a no carbon-carbon double bond. So we can say that 93 having option C is the correct one. Which of the following facts regarding I3 negative are incorrect? So you have to calculate which of the following fact is incorrect regarding the this. So this one that is there are two I atoms around the central I atom that occupy the equatorial position. So this one is incorrect, right? The correct structure for the I3 negative is I, and I. So they having the negative charge. So they having 2 to 4 to 6. 2 to 4 to 6. Right? 2 to 4 to 6. So this is how we can actually draw that. So there are two I atom around the central atom. I atom that occupy the equatorial position, or this is an axial position. Next, in which of the following compound does the sulfur obey the octet rule? So you have to identify in which of the following they obey octet rule. So basically in sulfur chloride HCl2, because this is the structure of HCl2, this is Cl, this is again Cl, they have been 2 to 4 to 6, 2 to 4 to 6, right? And sulfur also having 2. So this is in which of the following compound that sulfur have of the octet rule, obey the octet rule, that is in Cl2. Now, in the symmetric molecule, have a zero dipole moment only if all their bond angles are equal, all bond energy identical, there are no lone pair of electron on the central atom. So you have to identify which statement is correct, right? So we know that for 96 question, that is symmetrical molecule have the zero dipole moment only. So hence we can say that because all their bond angle are equal, no. All bond length are identical, no. So there are no lone pair, so on none of the correct. So none of the correct are the correct answer for this question. That is question number 96 for you. Considering the formation of O2 negative to O2, the change involved increase in the stability. So what the main change? That is change in the magnetic moment. Number of unfilled electron is decrease. So we can say that there is a change in the magnetic moment. Now, the next question is a mixture of N2 and S2 is caused to react in the closed container to form NH3. Okay, the reaction ends. Okay, let me just wait for a second. Okay, so a mixture of N2 and S2 are caused to react in the closed container to form ammonia. The reaction end before either reactant has done totally consumed. At this state, 2 mole of each N2 and S2 and NH3 are present. The mole of N2 and S2 present originally were respectively. We have to calculate originally how many moles of this were present. Right. So let me write the reaction first. So we know that this is N2 plus 3H2 and this will produce 2NH3. So this is the basic reaction, right? So we can say that the 2 mole of ammonia are formed for the every 1 mole of N2 and 3 mole of nitrogen. Huh? So for the every 1 mole of nitrogen and 3 mole of nitrogen, 2 mole of ammonia will get. Right? 2 mole of ammonia will get. Right? So this is a very simple one. Now, since we are given that the 2 mole of ammonia are present, then they must have been formed by the consuming 1 mole of N2 and 3 mole of hydrogen. Because they're asking 2 mole of ammonia only, right? So for 2 mole of ammonia, we have only 1 mole of N2 and 3 mole of H2 is required. Thus means that the original amount of nitrogen, that is the amount currently present plus may amount consumed, that is currently amount present is 2. That is nitrogen के लिए currently क्या है 2 and amount consumed is 1. That is originally 3. That is 3 mole of N2 is present. On the similar basis, originally amount of hydrogen present is that is required, that is 3, and present is 2, that is 5. So 3 comma 5. So which of the following option is correct? That is B, right? So that is 3 comma 5. No, it's correct. Now the next is on heating the pure limestone, dissociate calcium carbonate into calcium oxide and CO2. If 200 gram of limestone is heated in an open container, compute the reduction of its weight. So you have to calculate the reduction of its weight, right? So this is a very simple question, just like this. So we know that on the reaction, thus for the every 100 gram, right? 100 because CaCO3 having the molecular mass of calcium. Let me write this equation here. This is calcium carbonate. This will give us CaO plus CO2. Right. So molecular mass of CaCO3 is what? That is calcium is 40 and this is 48 and this is plus 12. This is 100. So for the every 100 gram, we get 44 gram of CO2. Hmm? We get 44 grams if the 200 gram of limestone in the open and complete reduction weighting. So 100 gram gives 44 grams. So using the unitary method, 1 gram gives 44 upon 100 and 200 gram give 44 divided by 100 into 200, right? So this will reduction is nothing but that is 88 gram, right? So can you calculate this? Yes. So we can calculate like this: 44 gram weight is lost. So for every 100 gram molar mass of CaCO3, 44 gram weight is lost for 100 gram. So for the 200 gram, how many losses? 44 into 2. that is 88 gram, right? So which option is correct, beta? That is B. Now, the next question is, that is the last question, that is the 30 gram of substance of molar weight, 15 mu when dissolved with the 21.7 gram of water, will the solution having density this? You have to calculate the molarity. So this is a very simple concentration defining term question is, so you have to calculate the molarity. So for molarity, what we need? For molarity, we use number of moles, and this will be divided by density of the solution. Density of solution. So this is nothing but the number of moles divided by the density of the solution. Now, how will you calculate the number of moles? The number of mole is already given, I guess, 30 gram of substance. So weight is given, so you can calculate the number of moles. So how will you calculate the number of moles, beta? So weight is given, that is 13 divided by 15 gram. So 13 upon 15 gram per mole. So this comes out to be 2 mole, right? So mole is already given. Now, from the density, we know the density is equal to mass upon volume of that solution. So volume is equal to mass upon density. So mass is 2170 plus 30 and volume is 1.1. So this is equal to 2200 divided by 1.1, or they comes out to be 2000 ml, or in liter we can say that 2 liters. So volume is also come, number of moles is also done. So number of moles is equal to 2 and this is also 2. So this comes out to be 1 molar. So the answer is 1 molar. So which one is correct, Peter? That is option number D. So we solve all the questions of this AIT 2 solution from question number 51 to question number 100. Right. So try to understand this question, try to learn from your mistake, and no, next time prepare all very well. Right. And try to learn कि कहाँ पे तुम लोगों ने गलतियां करी है ना, in which point you need you may no you require to work hard, right? So this is all for the today class. Let's meet in the next class where we'll discuss all the next thing. Till take care and just study, right?